Hello students, in this session we will discuss about the parallel RLC circuit. First, draw the circuit diagram. A single phase AC supply is applied to the parallel RLC circuit. This is R and second one is L, third one is C. So, a single phase AC supply. So, same as previous RL and RC circuits, any parallel branch, all the voltages are same. Just write down that. Supply voltage and voltage across resistance, voltage across inductance and voltage across capacitance, all will be the same. Next, currents. So, this is the parallel branch. The current is supplied from the source. Assume that is I, and it's supplied to the current IR and supplied to the current IL and is supplied to the current IC. This total current I will be divided here because it is a node. That is IR, IL, IC. Write down that. So that is IR plus IL plus IC. This is the current. So find out each and every current and each and every voltage. First, voltages all are same. Just note down that is supply voltage will be equal to the resistive voltage and the inductive voltage as well as capacitive voltage. Assume that is Vm sin omega t. And find out each and every current here. The first current IR, the current IR equal to flowing through the resistor. So it gives voltage across the resistor by resistance. Same voltage across the resistor by resistance. The voltage across the resistor means this is the thing. Just note down this. That is Vm sin omega t by R. So finally we can write like this. This Vm by R is Im. Better to take not Im. This is the R. R maximum value. This is. So maximum value. Right, sin omega t. So from this we are finding instantaneous current. So instantaneous current is current I equal to IR max sin omega t. So regarding to the IR is completed. From this we can write RMS current like this. So from this we can find out RMS current. Resistive RMS current is simply resistive maximum current by root 2. Current by root 2. This is about the current flowing through the resistor. Next thing, current flowing through the inductor, IL. Next thing is the IL. IL is same thing, voltage across the inductor by inductive reactance, JXL. So voltage across the inductor is nothing but the supply voltage. The supply voltage equal to Vm sin omega t by JXL. If you convert into the polar form, that is XL at an angle of phi by 2. So by modifying this we will get Vm by XL, take it as omega L, no problem, and sin omega t minus phi by 2. Sin omega t minus phi by 2. So from this we can write it instantaneous inductor current. Instantaneous current of inductor is, name it as IL. That is, you can write IL, better to keep maximum, sin omega t minus 5 by 2. So from this we can write RMS value of the inductor current. RMS value equal to maximum is equal to IL max by root 2. IL max by root 2. So better to write here IL max by root 2. So two currents are completed. Remaining current is current flowing through the capacitor. So current flowing through the capacitor, look at here, voltage across the capacitor by the capacitive reactance. So this is current flowing through the capacitor, IC equal to voltage at the capacitor and capacitive reactance. Capacitive reactance we can write minus JXC. Current flowing through the capacitor equal like this, Vm sin omega t by, we can write XC at an angle of minus 5 by 2. This is minus 5 by 2. We can write it as Vm by XC sin omega 2 plus 5 by 2. And it will be modified like this, Vm, what is XC? You know that XC is omega C into sin omega t plus 5 by 2. So finally we can write the instantaneous capacitive current. So instantaneous capacitive current, IC equal to IC max sin omega t plus 5 by 2. From this we can write RMS capacitive current, RMS value of the capacitive current equal to maximum capacitive current by root 2. This is the capacitive current. Now we will understand complete current. So before writing the complete current, just look at what is the current relation between all these things. So in order to assign a sign, just better to take the current values. So from this equation we have to write the current value is simply, so current equal, we can write like this, current equal, generally current equal we can write like this, so resistive current plus inductive current, capacitive current. But if you observe here, the current values are like this. That is, here the current IR equal to, we already written V by R. What about this? V by minus JXL and V by minus JXC, right? V by minus JXC. So if you modify this, and again we will write this V by R and if plus J is there, that it will become minus J V by XL and plus J V by XC. So finally we can write like this the current value. The current value is simply, this is IR and minus J IL plus J IC, simply. By adding all those things, so we will get minus J here plus J here, because it's a current. So this is about the supply current. So finally supply current magnitude we can write like this, supply magnitude I equal to real part and imaginary. Real is IR square and imaginary is IC minus IL square. Why it is? Here plus IC there, minus IC there. There is no problem actually, because it is the square term. IC minus IL or IL minus IC, no problem. But in order to understand the sign, we are doing all these things. So finally, the supply current I equal to IR square plus IL minus IC. IL minus IC. Okay. Just substitute thing, we will get that. Now we will draw the phasor diagram. Phasor diagram is very important here to understand the concept. So draw the phasor diagram. Phasor diagram. So for writing the phasor diagram, first, what is the common thing here? What is the common thing here? Common thing is the voltage. All the voltages V, VR, VL and VC all are same. Current flowing through the resistor is similar to the voltage supply. Inductor voltage VL, IR is here, but capacitive current always, look at here, capacitive current always plus 5/2, that means leading. So write the capacitive current here. So low value. So this is the capacitive current. Inductor current minus 90, so that's why. So this is the inductive current. This is the difference between the inductive current and capacitive current. So IL minus IC. IL minus IC. So the combination of will give the supply current. Sometimes if IL is greater than IC, we will get IL minus IC. If IC is greater than IL, we will get like this. This is the power factor angle. The voltage and current is the power factor angle. Now we will write the power factor angle and directly power factor. So power factor angle like this. So phi equal tan inverse of applying the tan here. Tan inverse tan equal opposite side by adjacent side. What is opposite side? This is opposite side. IL minus IC is opposite side. IL minus IC is opposite side by opposite side by adjacent side. Adjacent side is IR. This is the power factor angle. And the power factor, directly we can write the power factor. The power factor cos phi equal opposite side by, adjacent side by hypotenuse. Adjacent side is IR and hypotenuse is I. This is the power factor formula. This is the power factor formula. Understand? So this is about the parallel RLC circuit. So in the parallel, this is the diagram and this is the division. It is same as parallel RC, but extra thing is added. Whenever the extra thing is added, you have to consider the extra current is there, extra voltage is there. But parallel voltages are same, but current is different. Voltages are same, current is different. Okay. Only one thing, in the parallel circuit, the branch voltages are same, but current will be varied. Okay. This is the problem regarding the parallel RLC circuit. Same as the RL and RC. Just write down the given data. So here the given data is, write down the given data. So here the given data is a parallel RLC circuit is energized by the sinusoidal voltage V equal same value, that is 100 sin 1000 t volts. and he is given R equal to 10 ohms, and second L equal 5 millihenry, 5 millihenry, C equal 100 microfarad. Question is obtain the instantaneous RMS values and currents and power factor. If you observe all these parallel circuit, I take only one model problem, so to understand easily and to understand the difference between all the circuits. That is the reason I am taking this only one problem. I repeat it for all the methods. So better to draw a diagram. So this is a single phase AC supply is applied to one R, another one is L, another one is C. That is parallel RLC circuit. So here same thing, which is a parallel branch, that's why we voltage across each element are same, but the current will be divided. The supply current will be IR plus IL plus IC. Look at here, this is the current, it will be divided into this is IR and this is IL and this is IC. So now you have to find out each and every current. Before that we have two things. One, inductance is there, so we have to find out the inductive reactance. So just find out the inductive reactance, XL equal to omega L. So omega value is, this is the omega value 1000, from this omega value equal to 1000. So 1000 into L equal to 5 millihenry. So this is cancelled. Finally we will get the 5 ohms. So from this XL value is 5 ohms, 5 ohms. So better to keep away, this is, it will give some clarity. If we keep away, this will give some clarity, right? Next we have to find out the XC value. XC value is 1 by omega C, 1 by again omega 1000 into C 100 micro means 10 power minus 6. So we have 1 by, finally we have 10 power minus and y, 3 plus 2 5 is there, so that is 10 ohms. So from that we will get XC is 10 ohms. Here XL is 5 ohms, XC is 10 ohms, right? Okay, so this is completed, and we have to find out each and every current here from the question. First you have to find out the IR, resistive current. Resistive current is simply resistive voltage by resistance. Resistive voltage is VR by the resistance is R. VR is nothing but equal to V only. What is the V value? V value right here, same 100 sine 1000 T by 10. So 10 times. This is the 10 sine omega T. So this is instantaneous current. Instantaneous current IR equal to 10 sine 1000 T. And from this we can find out the RMS. Resistive current RMS equal to 10 by root 2. So this is the resistive instantaneous current, this value, and this value is the RMS current. Now we will find out the inductive instantaneous current and RMS current. So inductive current equal to same as inductance voltage by inductive reactance. So inductance voltage is nothing but equal to this voltage. So write that. So that is 100 again sine 1000 T by JXL means 5 at an angle of 5 by 2. Simply. This is 20 times, it will be cancelled, and so we can write like this. It is 20 sine 1000t minus 5 by 2. So from that you can write inductive current IL equal to inductive current, instantaneous current IL equal to 20 sine 1000 t minus 5 by 2. Next, IL RMS equal to 20 by root 2. So so inductive current is this value and IL by root 2 is 20 by root 2. Now we will find out the capacitive current. So the capacitive current formula is capacitive voltage by capacitive reactance. Capacitive reactance equal to minus JXC. Capacitive voltage nothing but the supply voltage only, because it is a parallel branch. So write down 100 sine 1000 T is the supply voltage by XC is 10 at an angle of minus 5 by 2 directly. So this is 10 times cancel and remaining thing is 10 sine, this is minus 5 by 2, if it is go to the numerator it will become plus 1000 T minus 5 by 2 will become numerator, that will be plus 5 by 2. So this is the instantaneous current, capacitive current, that is 10 sine 1000 T plus 5 by 2. 5 by 2. So from this we can find out capacitive current, RMS capacitive current. We can write 10 by root 2. We can write 10 by root 2. Okay. These three currents are completed. What is our required current? Our required current is supply current. Supply current magnitude. So just finding the supply current magnitude. So we require another thing is the supply current magnitude. So supply current magnitude we can write directly from the formula. The formula is real part square I square plus IC square minus IL. So this is combination actually, not individual squares, completion of the square. This is IC minus IL square. So write down what is I value. I will not I, this is IR. Understand? Resistive square, capacitive minus inductive square. So IR, you know that this is 10 square. These are the supply current, we are finding directly the RMS supply current. So we have to write all the RMS values. IC RMS and this is also RMS. So you know that what is the RMS value of the resistive current? Look at the RMS value, 10 by root 2. Resistive current is, this is the 10 by root 2, right? So it's right here, 10 by root 2 whole square minus capacitive current equal to 10 by root 2 minus inductive current equal to 20 by root 2 whole square. So by simplifying this, we will get finally, so 10 by root 2, 10 by root 10 by 2 minus 10 by root 2, again it will become, this is 100 by 2, again this is 100 by 2, 200 by 2, then will become 100 here. This is, we will get root 100 here. So finally we will get 10 value. We will get RMS value is 10 amperes. So therefore supply current is, name it as I is 10 amperes. Okay, clear. Now we will find the power factor. So power factor equal to supply power factor equal cos phi equal to IR by I. Simply IR equal to, you know that power factor IR equal to, this is RMS values. Again, don't confuse here. This is RMS value. Always in the calculations in power factor or in the effective values are only RMS values. Okay, right. So RMS value is 10 by root 2 there, and this is the 10. Okay, 1 by root 2. 1 by root 2 means 0.707. This is the power factor. The power factor angle, if you apply cos inverse of 0.707, you will get phi equal to, I think 1 by root 2 means 5 by 4. 5 by 4. So in order to understand clearly, just simply you draw a phasor diagram, then you will understand very easily what happened inside the circuit. So for that I am removing this. I think all of you note down all these things. Better to note down before the things. So better to draw the phasor diagram by using all these values. So for that I take in this space for the phasor diagram. Right. First thing in the phasor diagram, you have to draw the voltage phasor, supply phasor, and we have some phase current IR, that is 10 by root 2 at an angle of 0. We know that. And we have inductive current is there. Inductive current always like this, but this is the gives, generally this is the inductor current is more value, I think 20 by root 2, that's why I taken the big value. So this is the inductor current. Inductor current always minus 90 degrees, that's why this is the minus 90. And we have the capacitor current is there. Capacitor current is always plus 5 by 2. This is the capacitor current. The combination of inductor current and the capacitor current is, the combination of inductor current and the capacitive current is, so IL minus IC will give some value here. I think this is the value. I assume that this is the value. IL minus IC. Why IL minus IC? IL value is 20 by root 2. Look at here. IL value is greater than IC. Why? Here IL value is 20 by root 2. C value is 10 by root 2. These are the RMS values. Now you draw the combination of IR, IL minus IC. So the combination value is current I. Okay, that's why we will get, look at here, exactly we will get the 5 by 4 here. Look at here. What is the power factor angle we will get here? 5 by 4. And the power factor is same thing. I think you understand. And this we will get the plus 5 by 4 and lagging. The final current is lagging. It is inductive in nature. Why inductive nature? Here inductance is dominant. Inductance is dominant. Inductance is, why inductance is dominant? XL value is more than the XC value. XL value is more than the XC value. If it is IC value is more than IL, then capacitive is dominant. Capacitive is dominant. Look at here. The final current is this value, that is RMS value is 10 amps we will get here, and the power factor angle is 5 by 4. If you do the cos 5 by 4, this is the value. Okay, this is the procedure to do the by giving the RLC parallel circuit. RLC parallel circuit. So same as the RL circuit, but extra thing is come, and you have to do very careful all these problems. Okay. Whenever inductor is dominant, the power factor is lagging. Power factor lagging means the supply current is below here and angle is like this. Whenever the capacitor is dominant, automatically supply current is leading, so it will be dominant. Okay, this is the problem regarding the RLC circuit. Okay, thank you.